Okay, today what we're going to talk about is how stars form. These are going to be some large stars. We're going to talk about the 8 solar mass all the way up to 25 solar mass stars. What I'd like you to do is get blank sheets of paper, copy paper. You're going to need some compasses, something like this. They're in the back of the room, in kind of the cabinet area. And you're going to need some colored pencils. So what we're going to do is we're going to draw the sequence of events that goes through the life of these types of stars. Okay, so with that, I'm going to turn the document camera. And you may need to pause this playback, and you can do that as much as you need to, but I would like you to draw the whole sequence here, and then I'm going to have you turn it in. Okay, so the ones that we're talking about are the high solar mass main sequence stars, so 8 solar masses up all the way up to 25 solar masses. Like all stars, it starts out as a nebula, so you can draw that as your first step here. Just a bunch of gas. Depending on the stars around it, it'll glow different colors depending on what type of elements are in the gas. So you can pause it at this time, and then when you've finished the nebula, drawing the nebula, then you can continue this. Okay, when gravity starts pulling it together, then we get when we get a lot of mass in the star, enough mass, enough gravity squeezing it together, eventually we'll get hydrogen fusion taking place. So you're going to need to draw 2 circles here, one inside the other. On the outside is a shell of hydrogen that's not doing anything. It's in terms of fusing, it's just hydrogen around the outside. And then in the center, the hydrogen starts fusing and changing into helium. At this point, it's a main sequence star. And this hydrogen fusion for an 8 to 25 solar mass star will occur for between 7 million years and 100 million years, depending on the mass. Okay, so I'll pause, or you can pause it at this point and continue drawing this step. When you finish, then we can continue. Okay, the next step is called the red giant phase. The star will turn into a red giant. What happens is eventually enough of the hydrogen has turned into helium, and the helium since it's got more mass, gets pulled towards the center. The helium starts congregating at the center, and because it's a lot more massive than many of the other previous stars, it has enough gravity, force of gravity, that it squeezes it together enough that it starts fusing helium. Okay, so when it starts fusing helium, it'll start contracting, and it fuses it into carbon. Okay, so we've got carbon starting to form in the very center. The most of the core, though, is helium. But as you go out, gravity is less and less, and most of the helium has sunk to the bottom. So you have hydrogen fusion occurring in a shell outside the helium. Well, because it's hotter now, kind of farther out towards the edge, this lighter gas, it causes it to swell, and so our star grows. So in this red giant phase, we have helium fusion beginning, and due to the large gravity, and it continues for about 500,000 years. While it's doing that, helium fusion still occurs in a shell, and it causes the star to swell. So you can pause it right here so that you can see this, and then once you finish drawing this stage, then you can continue. Okay. Again, you're going to need your compass. You're going to need to draw 4 different circles, each one larger than the other. And this is the red supergiant phase. The carbon that was forming due to helium fusion in the core sinks to the bottom, and because there is enough gravity, it starts the carbon to fusing. Okay, so around the outside of the carbon, and it fuses it into the carbon into neon. Because the carbon, or there's still helium on the outside of the carbon, it's still fusing, and there's still some hydrogen fusing in a shell outside the helium. Okay. It continues to swell because now we have hotter temperatures, again closer towards the surface, causing the gas to swell even more. Okay. Again, you can pause it at this point, and then and when you're finished with this part, you can continue. All right, this next phase is kind of actually several put together. We said that the carbon fused into neon. Well, the same process occurs after the neon starts fusing. Then it fuses into oxygen. Once the oxygen fuses. It fuses into silicon. But this process starts happening, or starts going faster and faster. In our red supergiant phase, this only continues for about 600 years. So if you look what we started with, we started with the main sequence star. It was there between 7 million and 100 million years. And then the red giant phase was 500,000 years, so 500,000 years. Then the red supergiant phase for 600 years, so notice it gets faster and faster. Once the carbon or the neon starts fusing into oxygen, the process starts going even faster still. So for this one, 1, 2, 3, 4, 5. You're going to need 8 circles, each one bigger than the other. Again, it's called the red supergiant phase. But the times that are involved here for the neon fusion, that occurs for about a year. The oxygen fusion occurs for about 6 months. The silicon fusion occurs for about a day, where it's fusing silicon into iron. Okay, because it's fusing these things so fast now, our core is collapsing. So the center part here, below the carbon, is starting to collapse really fast. Well, when it collapses like that, it builds up a lot more pressure. So the star is collapsing into a core of iron. Okay, and I guess I should let you finish. You can pause this, finish the drawing, and then move on to this next one. Here's where things start getting interesting fast. The star starts collapsing in towards the iron core. The temperature shoots up to about 5 billion K. And once it does that, the pressure builds up so much that it turns into a type 2 supernova. Basically, it explodes. Okay, so you've got a lot of this gas rushing in, the temperature shooting way up. That temperature shooting way up provides a lot of pressure going out, so it creates an explosion, which is a type 2 supernova. Okay, and for our 8 solar mass to 25 solar mass star, what we end up with left is something called a neutron star. As it was all compressing in, basically it took electrons, shoved them in with protons, so forced them together in the nucleus, and turned it into just a neutron. And that's all the star is made up of, are neutrons. So they call it a neutron star. Okay, it doesn't give off a lot of energy at that point. As a matter of fact, it doesn't give off a whole lot. It's just a bunch of neutrons all jammed tightly together. with a lot of mass and very dense. Okay, feel free to back this up to any stage you need, but finish this drawing out and then turn in your drawings. Make sure your name is on the back of it so that I know whose it is. What I'd like to find is some that we can post and show around or out in the hallway. And what we're going to look at tomorrow is the ones that are bigger than 25 solar masses.